So number 13 on the review problems.
Yes, I did not.
Okay, a chemist is making two different compounds from the same two elements, nitrogen and oxygen. To make the first gas, she reacts 10 grams of nitrogen and 11.42 grams of oxygen. All right, so let's write that down. This is the first class had the question about the same type of problem. So 10 grams of nitrogen reacted with 11.42 grams of oxygen to make 21.42 grams of the first gas. So some gas, right? Some gas. All right, so suppose she starts with 10 grams of nitrogen again. Actually, this is not the kind of question that the first class had. 10 grams of nitrogen again. So we're starting with 10 grams of nitrogen, but wants to make a completely different gas with no leftover oxygen. Should she use 20.5 grams? So the options are 20.50 grams, 22.84 grams, or 35.12 grams of oxygen. Which one? Who can give me the law that's going to tell us how we figure out the answer to this problem?
The law of mass proportions?
You're close. This would be the law of multiple proportions. If we have two compounds that are comprised of the same two elements, right? So like for example, we did the lab where we had water comprised of hydrogen and oxygen, and then we had hydrogen peroxide, also comprised of hydrogen and oxygen. If you have the same mass, the same amount of the first element, and you combine it with the second element, the first compound that's made, you're going to make a compound the first time, which in our case with the water example would be water, and then the second compound would be hydrogen peroxide, because remember water is H2O, hydrogen peroxide is H2O2. If we have the same amount of hydrogen, if this amount doesn't change, let's just say we have 10 grams of hydrogen for argument's sake, right? The amount of grams of oxygen that are required, we're just going to throw something out in the air. I don't know if this is accurate at all, but we'll say 16 grams of oxygen. The ratio between the amount of oxygen here and the oxygen here, because the amount of hydrogen didn't change, we had 10 grams both times, the ratio between these numbers, the mass amount of this, has got to be a simple whole number, a small whole number, right? And so the options for the oxygen here is it could be, well, because we know there are two oxygen molecules, this one has to be 32 grams, okay? And so the ratio then would be 32 divided by 16, which equals 2. All right, it won't be a decimal number. It won't be 2.5 or 2.35 or anything like that. And so that's what this is asking us here. It's saying the amount of nitrogen doesn't change. So which of these would have to be accurate with the oxygen? So all we have to do is figure out what the ratio is of this number to this number. And whichever one turns out to be a whole number, that's the correct answer. All right? So we first do 20.50 divided by 11.42. By the way, some of you guys got this wrong on the test, so we needed to go over it anyway. If you see a number on the test, let's just say it's something like that, and then you see a slash and 11.42 grams, what does that mean? It means divided by, right? And so my assumption was, based on you guys having Algebra 1, that everybody would know that, right? That's because, that's this whole, why do we say that that's equal to 0.5 as a decimal? It's because we recognize that 1/2 is 1 divided by 2, right? And so it's the same thing here. If you see that, that's just another way that you can note divided by. So I want to make sure everybody knows that whenever you see the slash, that simply means divided by, okay? So 20.5 divided by 11.42, what's that number? Everybody done that calculation for me?
1.7950.
Yeah, so it's not 5, okay. It's not a whole number. What about this one? 22.84 divided by 11.42. 2! It sounds like we may have a winner. Let's check this one out, right? 35.12 divided by 11.42.
3.07.
It's a decimal, right? 3.07, whatever. So this has got to be the correct amount because the ratio is a simple whole number, okay? And the reason the ratio has to be a simple whole number is because when you're chemically combining things together, you don't combine half atoms, right? It's always a whole atom that's combined. It's not H2O and then H2O 1.5, right? So that's why the math works out like that. if the mass of this first element stays the same. Okay, so that's what the law of definite proportions tells us. Does that make sense, Lily?
Yes.
Okay. Any other questions? In number 7, we had 54.94 grams of manganese, which manganese is just Mg. Where's that magnesium? That's magnesium, yeah. Mn probably. Yep, Mn is manganese. So Mn, 54.94 grams of Mn plus 32 grams of oxygen yielded 86.94 grams of this powder. Okay? And then they said if we have 144.94 grams of powder, how much of this stuff do we have that made that? So how do we figure that out? Well, again, we find our multiplication factor. We find that out to be 144.9 grams divided by 86.94 grams. And then 144.9 divided by 86.94. 1.67 is our multiplication factor. And so then we take each of these numbers and we multiply them by 1.67. So the first one is 54.94 times 1.67 equals 152.92. And it was multiplication, and technically I should only have, I should just have one as far as the significant figures go, right? Mn plus, we have 4 significant figures there, 86.
I think that
Oh, I went
answer
I did
should
it the
have
other way.
4 sig-figs for the 1.67.
Say that again.
Isn't that supposed to be 1.667?
Did I do that right? 54.94 times 1.6. Yeah, I see what you're saying. Hang on just a second. 54.94. I'm going to tell you guys something that's really going to make you happy, okay? So I did that wrong. I multiplied the wrong thing. I don't know what I multiplied wrong. But this should be 91.75. 54 times this multiplication factor gives you that. 32 times 1.67 gives us 53.44 grams of oxygen. So if we add those together, we should get something that's pretty close to that, 91.75 plus 91.75 plus 53.44 equals 145.19, pretty close. So the significant figures, is that what your question was about?
Because the least amount is 4.
You're exactly right. Let me tell you guys about significant figures. I needed you guys to learn about precision and learn about significant figures because that's the right way to do it. And I want you to understand that when you see that in a college course in the future. But there are concepts that I want you guys to get, and I don't want you stressing about precision and significant figures for the rest of the year. Okay? So, just round to 2 decimal places. All right? If you round to 1 or 2 decimal places, I'm going to be satisfied with that. As a rule, I'd say round to 2 decimal places. All right? So, going forward, I had to test you on that material, and I had to make sure you understood how to do that, and everybody's got working with precision and significant figures, right? You got that down? But does everybody agree I'd rather not have to worry about that so much going forward and just round to 2 decimal places? You guys good with that? Okay. You feel like I'm cheating you scientifically? No? Okay. All right. So are you okay with that? Will you let me off the hook on that? All right. But she's right. All right. We shouldn't use 4 significant figures there, so we would have put 1.667. And our numbers would have come out a little bit better had we done that, right? This would have probably been closer to 144.9. But so that's what we had originally. And so number 8 says, in an experiment, the chemist reacts. So it gives us a new reaction, and it says he reacts 7.85 grams of manganese with 2.29 grams of oxygen to make 10.4 grams of a powder. So the question is it the same powder as in problem number 7? Well, if it is, then we should be able to take the ratio of this to our original one and then multiply that by our original recipe and get these numbers. So let's see. So the ratio of 10.4 grams to 86.94 grams, which is what our original recipe was. This is the way that I'm going to do it. There may be another way that you can get to this. I mean, you could use the new recipe. There may be other options here, but we can tell it from this. So 10.4.
1-4.
10 point, was it 1-4?
Yes, sir.
Okay, sorry. So there's a 1 here? Like that? Okay, 10.14. 10.14. It is I, right?
Yes.
Okay. 10.14 divided by 86.94. All right, so that tells us that our ratio between these two is 0.11. I'm going to go ahead and do that 3 there just because we don't have a number in front. 0.117. All right, so if I multiply 0.117 by this, I should get this number. And if I multiply 0.117 by this, I should get this number if it's the same powder. Okay, so let's see. 54.94 times 0.117 equals 6.4, I don't get quite the same, 6.43. If I do 32 times 0.117, I get 3.74 grams. So I hope that the answer in the book was they're not the same. Was it? Okay. So, and that makes sense because when I multiplied by the multiplication factor, I didn't get the same numbers here, so it can't be the same. I modified my recipe to match this multiplication factor, and it didn't come out right. Okay? Is that clear to everybody? I hope I didn't confuse you further, but again, this is just, think about brownies and making more or less brownies. If I had 12 brownies and I need to make 6, then I cut the recipe in half, right? My multiplication factor is 0.5. So that's how you need to think about this multiplication factor thing. If you can keep that in mind, then you'll be able to do these problems as well. Okay?